All right, how's it going, Benj?
Good.
Good. Thanks so much for joining me for this Zoom session. We are going to just go over the review sheet that was posted in Google Classroom. I thought we would go over the first 3 problems and you could try the other 3 independently just to test your own mastery. So what I'm going to do is I'm going to go ahead and share my screen, which will have the review sheet on it. I'm hoping you printed it out. Did you print it out?
Yeah.
Awesome. Okay. So on my screen, you see the handout that you have, correct?
Yes.
Awesome. So let's go ahead and we'll just work through these problems. Would you mind reading problem 1 for me?
The average lifespan of an American woman has been tracked, and the model for the data is y equals 0.2t plus 73, where t equals 0 corresponds to 1960. Explain the meaning of the slope in the y-intercept.
Thank you so much. So these types of problems were what we did in the beginning of the week. And just as a refresher, they're starting this model at the year 1960, and they're saying that corresponds with time equals 0. So my question to you would be, let's say I plug t equals 20 into that problem. What year would that give me the life expectancy of a woman for?
1980.
Awesome. If I plug t equals 40, what year would that give me the life expectancy for?
2000.
Awesome. So you get that. But let's talk about what the slope and the y-intercept actually mean in the context of this problem. What number is the slope in this problem?
0.2.
Okay, so what does 0.2 mean to us?
Well, so basically it's saying that that's the amount of time a woman's lifespan would increase.
With each year, right?
Yeah.
Okay, what is 0.2 of a year? How could we figure that out and put it in more relatable terms?
That would be 2.4 months each year after 1960.
Yeah, so what you do is we just take, we know 12 months are in a year, right? And we multiply 12 months times 0.2, and that tells us, well, with each year, a woman's life expectancy should go up 2.4 months. Now, why would that be the case? Because we have better nutrition information, we have better medications, all of that. So very good. What is the y-intercept in this problem, and what does it mean?
It would be the value when t equals 0.
Okay. What is the value when t equals 0?
It would be, well, the y-intercept would be 0.
Well, the y-intercept's not 0. You were right. You find the y-intercept when you plug 0 in for t. If I plug 0 in,
it would be 73.
It's 73, right? Because if I put 0 in for t, I get 0.2 times 0. That's 0, right? Plus 72 is 73. What does 73 mean?
That means that's how many years the study would go on for.
Not necessarily how many years the study would go on for.
How many months it went up. How many years it went up.
Well, in terms of years, it would be how long you would expect a woman to live at the very beginning of this study, right? When did this study start?
1960.
Okay, so that's what the y-intercept is. It's the life expectancy of a woman in 1960. Does that make sense? Because that's when the whole thing begins. At time.
Yeah.
Awesome. Okay, let's go on to problem 2. So in the middle of the week, we started to study about lines of best fit, because we know that in most situations in the real world, when you're plotting data, it's not going to form a perfect line. You know, it's going to form a scatter plot, but it could have a trend that shows a positive correlation, a negative correlation, or no correlation. The one on our screen obviously shows a positive correlation, right? Because it's rising from left to right. And when we're drawing the trend line, do we try to place it in the middle of the data, above the data, below the data? How do we try to place it?
Well, first we need to find what y equals, which would be mx plus b.
Well, you're
But
right.
that-
No, you're totally right about that. What I was asking is when you're initially trying to draw a line through all those
Yeah.
blue points to try to get an idea of an equation that would fit it, you try to draw that line through the middle of the data, above it, or below it.
Well, I'd say in the middle.
Yeah, you're right, because the middle's going to give you the average, right?
Yeah.
Cool. Okay. Back to the actual question. Sorry, I shouldn't have gone to a different subject, but I just wanted to keep it on your toes. What is the equation? So when we're writing an equation of a line, what's the form of an equation of a line?
Y equals mx plus b.
Perfect. We want to fill in for what two letters?
M and b.
M and B. Which one of those is slope and which one is intercept? Y-intercept.
So m would be y-intercept and b would be slope.
Can you switch that around?
B would be y-intercept and m would be slope.
Yeah, you got it. Okay. So the slope is the steepness of the line, right? Can you tell me how many, if you're looking at that black line that goes through the data, how many units do you move up and over to get to each point on this line? So you see we would go up and over to get, how many are we going up and over?
1 up and 1 over.
Okay, so if we wrote that as a fraction, 1 over 1,
Yeah,
what is that giving us? Just a?
just a 1.
Yeah, okay. So I'm actually going to type in, so far you've told me that y would equal, you just told me that the slope is 1, right?
Yeah.
I don't have to write the slope in there if it's 1. I can just, it's understood, so I can just put x. Now b is going to be what?
Negative 2.
How do I know it's negative 2, Ben?
Because if you're going down the chart, it goes to negative 2 if you're going 1 over 1 of a fraction.
Yes, you're right. So since we know we go up and over 1, we also know that we can go down and over 1 and down and over 1. So we would hit at negative 2. So that's the model. And I just typed it on the screen, y equals x plus negative 2. That would give us the equation. Then
Yeah.
I forgot to do that I want to do real quickly, and I'm going to come back up here. I did not type in those wonderful answers you gave me for this one, so I'm going to do that. Point 2 is slope, and it means that it means that the woman's life
will increase by 0.2 or 2.4 months each year after 1960.
or 2.4 months each year after 1960. You really summarized that well. Awesome. Okay, what does the y-intercept tell us again, or what was the y-intercept?
The y-intercept was 73 years.
Do you remember what we said that means?
Well, the y value when t equals 0.
Okay.
But in this problem, t equals 0 means the year 1960. So it's life expectancy of a woman in 1960.
Okay. So that's the life expectancy of a woman in 1960. Beautiful at the beginning of the study. Thank you. Okay, so last problem we're going to do is problem 3. It says the function below shows the cost of a hamburger with a different number of toppings. And you have f of t equals 190 plus 140t. The first question, what is the y-intercept and what does it mean? What is the y-intercept in that function?
190.
Okay, so 190. Now, do you think that should be in money?
Yes.
Yeah, because we're talking about cost here, right?
Yeah.
Okay, so you got it. That is our y-intercept. That's the B of the problem. What does that mean, though, in terms of the problem?
Well, it means it is the cost of a hamburger with 0 toppings.
Exactly. If we put a 0 in for T, and T means toppings, we're going to get back $1.90. So that'd be a plain old McDonald's hamburger. No, nothing on top, right?
Mm-hmm.
Okay. Let's say I'm going to type that in. The cost of a hamburger with no toppings. That's kind of a sad hamburger. I at least want bacon and cheese on mine. I'm just saying. I'm gonna change that to red real quickly just to set it apart. Okay, last question. What is the slope and what does it mean?
The slope is $1.40, and it is the cost of each topping.
Beautiful. Man, I think you're ready for this test. You feel ready?
I think so.
Okay, here's what I would suggest. Go ahead and finish the other 3 problems that are on this handout. And when you are done, I posted the answer key inside Google Classroom so you can check it just to make sure that you're all ready to go. Hey, thanks so much for joining me. I hope you have a great weekend.
Yep, you too.
All right, and tell your little brother I said hi.
Okay.
I'll try to, is your little brother in there?
He's right behind you.
Okay, I will see ya.
Goodbye.
Bye.
Wait, let's